in the figure below, OA is A vector, OB is B vector, and OC is 3 of OB. So OA is A vector and OB is B vector and OC is 3 of OB. So express AB and AC in terms of A and B. So the first part, that A, the vector AB, that is AB, is going to be AO plus OB. AO plus OB. So OA is A vector, meaning AO is negative of A vector, plus OB, which is B vector. And then we have AC vector. So to get AC, you're going to have AO plus OC. So AO, we have AO, but we do not have OC, but we have the information that OC is the same as 3 of OB. So we have AO plus 3 of OB. So it means we have negative A vector plus 3 of B vector. Part B, given that AM is 3 over 4 AB and AN is half AC, express OM and ON in terms of A vector and B vector. So OM, that is OM, so we can join to show that OM. So for you to go OM, you can go OA AM. So you can have OA plus AM. So we have OA, but we do not have AM, but we have been given that AM is 3 of AB. So we have OA vector plus 3 over 4 of AB. 3 over 4 of AB. So OA is just A vector plus 3 over 4 of AB. For us to get AB, we just go AO, that is minus A vector plus OB, which is just B vector. So you can simplify that so that we have A vector minus 3 over 4 A vector plus 3 over 4 B vector. So if we simplify this, we're going to have a quarter A vector plus 3 over 4 B vector. So we have expressed OM in terms of A vector and B vector. So let us now look at the other one, which is ON. So ON vector. So for you to go ON, let us join that. For you to go ON, you can go OA plus AN. OA plus AN. We have OA, but we do not have AN. But we have been given that AN is half of AC. So OA vector plus half of AC vector. So we can get AC. So that we have this as A vector plus half of AC. So AC, we have AC here. We had solved that, so just put that here. A vector plus 3B vector. So you can simplify that to be A vector minus half A vector plus 3 over 2 B vector. So that we have half A vector plus 3 over 2 B vector. Okay, so we're done with part B. Let us go to part C. hence show that this should be the points O, M, and N are collinear. So there are conditions for collinearity of points. The first one is that they should share a common point, and the second one is that they should be on vectors that are parallel to each other. So for these 3 points to be collinear, it means you identify they must be lying on two vectors that are parallel to each other and share a common point. So we can have those two vectors as OM. So we can make two vectors. We can take OM and ON. Yeah, we can use those two, and ON. So if that is the case, the first condition is met because they share the point O. So that first condition is met. So the second condition is that these two vectors should be parallel to each other, and if they're parallel to each other, we should have OM being equal to some scalar of ON. So this is what we're going to try to prove, and if that is true, then we will be sure that the 3 points are collinear. So we have OM as quarter A vector plus 3/4 B vector, and that should be equal to some scalar K of ON, and ON is half A vector plus 3/2 B vector. So we can open up this bracket so that we have a quarter A vector plus 3/4 B vector is equal to half K A vector plus 3/2 K B vector. So all we need to do is just compare the coefficients of A vector and then the coefficients of our B vector. So for the coefficients of A vector, we have a quarter being equal to half K. So this implies that K is equal to 1/4 times that, so that we have K as half, and then we compare the coefficients of B vector so that we have 3/4 is equal to 3/2 K. So this implies that K is equal to 3/4 times 2/3, and that is also half. So this means that the value of K is same for coefficient of A vector and for the coefficients of B vector. So it means therefore that the vector OM is half of ON. So this is a proof that they are parallel. So it means the 3 points O, M, and N are collinear because they share a common point. They share a common point, which is O, and they are parallel to each other. They are parallel because we have OM being a scalar of ON.